So we talked about elimination, where you have to use opposites to get a variable to drop out. So let's take a look here at this first example. I have 6x plus y equals 6, and I have 3x plus 2y equals 9. So if I wanted my my y's to drop out here, to make the y's opposites, I could multiply this whole equation by -2. If I wanted to get my x's to drop out, I could actually multiply the second equation by -2. For no particular reason, I'm going to multiply the first equation by -2, and remember, what we do to one term, we do to all terms. So everything by -2. I get -12x minus 2y equals -12. I kept my second equation the same. So now when I go to add these, my y's drop out. That's exactly what I wanted. They eliminate. So I have -12x plus 3x is -9x. Divide by -9. Be careful, that's not 3. That is 1/3. No panic. Remember, no fear of fractions. We can substitute in 1/3. It doesn't matter where we substitute it in. I went ahead and put it into the first equation. So I have 6 times 1/3 plus y equals 6. 3 goes into 6 twice, so I have 2 plus y equals 6. So I have y equals 4. So the solution to this system of equations is 1/3 4. This would not have been a great problem to do with graphing, the fact that one of our coordinates is a fraction. This wouldn't have been bad to do with substitution if we wanted to. We could have got y by itself. Okay, let's take a look at example 2. All right, so here in example 2, we've got a little bit different of a situation because we don't have any with a coefficient of 1. So we can make our choice. I could get my s's to drop out, or I could get my t's to drop out. Now, it doesn't matter, but if I had a choice, I'm going to go with the t's because one's already a negative and one is a positive. So how I look at this is, what is a number that 5 and 2 both go into? That is 10. So my LCM is 10, or just look at what is a number that 5 and 2 both go into. So what am I going to do to the 5 to make it a 10? I'm going to multiply by 2. So I'm going to multiply every term by 2. So I have 8s minus 10t equals 6. What am I going to do to make this 2 a 10? I'm going to multiply it by 5, which means multiplying everything in the second equation by 5. And I have 15s plus 10t equals 75. Now, please also note that if I have this, so I have 8s minus 10t equals 6, and I have 15s plus 10t equals 75. So having that, my t's are opposites. So if I add, I get 23s equals a -69. So s is -3. Do not forget, you have to substitute that back in to get the other coordinate. It doesn't matter where. I think I ended up putting it in the second equation. So 3 times -3 is -9. -9 plus 2t is -15. If I add 9, I get 2t equals -6. Divide, and I get t is -3. So I really think elimination was the best method on this. We could have got t by itself and graphed. That wouldn't have been bad. Substitution would have been tough because none of the coefficients are 1. Okay, let's take a look here at example 3. This one is a pretty easy example because everything is almost a coefficient of 1. So y's are already opposites. So if I add this, I get 2x equals 18, and I get x is 9. I got to plug 9 in for x. It doesn't matter where. 9 plus what gives me 17? That would be 8. So the intersection point would be 9, 8. This problem could have been solved by any method: graphing, elimination, or substitution. So just remember, you need opposites for elimination. So let's take a look here at example 4. These almost are opposites, except these are both plus 12. So as it doesn't matter which one I do, I'm going to go ahead and multiply my bottom equation by a -1 to get my 12s to be opposites. So -5a minus 12b equals a positive 1. So if I add these, or 8a minus 5a is 3a, my 12s drop out, and I get 21, and I get a is 7. So we have to remember, we have to substitute back in. That's only part of the answer. We need ordered pairs. So I'm going to plug 7 back in for A. I could have plugged it into any equation as long as I plugged it in for A. 8 times 7 is 56. 56 plus 12B is 20. I'm going to subtract 56, and I get negative 36. 12B equals negative 36, and B is negative 3. So my ordered pair, or the solution to this system, is 7, negative 3. Okay, so now what I would like you to do is, I would like you on your own, I'd like you to stop the video, and I would like you to do example 5. 9x minus 10y equals 2. 9x plus 2y equals negative 22. Okay, so if you did stop the video and did the problem on your own, I multiplied the bottom equation by a negative to get my 9's to drop out. That would make that a negative 9x minus 2y equals positive 22. So now I'm going to add negative 12y equals 24 and y equals negative 2. I have to substitute negative 2 into any equation. I decided to put it into the first equation. So I have 9x plus 20 equals 2. Subtract 20, 9x equals negative 18, and x equals negative 2. So the solution to this is negative 2, negative 2. I want to go over a couple of more that was on the video yesterday. I want to repeat these. So if we take a look at 2s plus 3t equals 35 and 5s minus 4t equals 7. None of these have a coefficient of 1. So we have to find opposites, but we also have to, in this case, we're going to have to multiply both equations by a number to get these to drop out. So since 3 and 4 on the t is already, one's positive and one's negative, I'm going to go ahead and get those to drop out. So what is the number that 3 and 4 both go into? That would be 12. So what am I going to do to the first equation to make that, excuse me, my thing just fell down. What am I going to do to this first equation to make that a 12? I'm going to multiply that by 4. So I have 8s plus 12t equals 140. Remember, every term by 4. What am I going to do to the second equation to make that, in this case, a negative 12? I'll multiply by 3. So I have 15s minus 12t equals 21. So if I add these, my t's drop out. I get 23s equals 161, and s equals 7. Don't forget, 7, I'm going to plug in for s. It doesn't matter where. I plugged it in to the first one. 2 times 7 is 14. 14 plus 3t is 35. Subtract 14, divide by 3, and I get 7, 7. So it didn't matter which one I chose, but something I want to bring up. If I decided I wanted to get my s's to drop out, we know that 10 is a number that 2 and 5 both go into. So I could have multiplied the first equation by 5, but then the second equation would have had to have been multiplied by a negative 2. So if you have a choice to pick a pair of numbers, if one's positive and one's negative, that may be the way to go. So I want to repeat on the video from yesterday as well. I could have got the w's to drop out or the z's to drop out. One's positive and one's negative. I went with the z's. I multiplied multiplied my first equation by 5 to make that a negative 20, and my second equation by 4 to make that a 20. So the key here is getting your a variable to drop out. They have to be opposites. Sometimes you just have to sometimes you just have to add, they're already opposites. Sometimes you have to multiply one equation by a negative to make them opposites. Sometimes you have to multiply one equation by a negative number, like a negative 2. Sometimes you have to multiply both equations by a number to get a variable to drop out. Don't forget, once you find one of the coordinates, you have to substitute that back in to find the other one, because the solution to a system of equations is a point, an ordered pair.